Good morning, students. So, I welcome you all for this another session. So, in the last class, we have started analysis of T beams, that is flanged beams. In that, we have seen how to calculate the moment of resistance for the case 1, that is when the neutral axis lies inside the flange. How to calculate the moment of resistance of T beam. Now, let us take another case, that is case 2. So, when the neutral axis lies outside the flange. Okay. So, in the case 1, it is a neutral axis inside the flange. Now, let us consider when the neutral axis lies outside the flange, that is neutral axis depth xu. Okay. This is the depth of neutral axis. Xu is greater than df. Okay. Xu is greater than df. So, for this case 2, when the neutral axis lies outside the flange, again there will be two conditions we have to consider. Okay. So, one is df less than 3 by 7 xu, no doubt, right? Xu is greater than df, that is neutral axis outside the flange. For this, again the one more condition you will going to consider, that is df less than 3 by 7 xu. Df means that is the depth of flange is less than 3 by 7 xu. So, one is neutral axis outside the flange. For this, then condition is df less than 3 by 7 xu. So, as usual, this is the sketch T beam. So, now the neutral axis is outside the flange. This is a flange. Now, somewhere the neutral axis comes here. So, from the top, this is xu. So, xu is greater than df. So, this xu is greater than this df, means it is outside the flange. And one more condition, df less than 3 by 7 xu. Now, again, so whatever this portion above the neutral axis, now see this all portion, okay, this all portion is considered as compression zone and this will be tensile zone. Okay. So, same thing I have drawn here. So, this is width of the flange, that is bf, then this is depth of the flange df, okay, and the neutral axis is here, and from this to here is xu. Okay. Again, this total section is divided into 3 now. Total section is divided into 3 parts, that is this is one rectangle. I have shown one, number 1, this is a rectangle, and these two are again rectangles. Okay. So, this total compression zone is divided into 2 rectangles. This is one, this plus this is second rectangle. Okay. So, again as usual, this is tensile reinforcement. So, for this condition, how to calculate the moment of energy, moment of resistance, okay, that is factored moment. So, now let us see when neutral axis lies outside the flange, okay, that is xu greater than df, two conditions we have to consider. Okay. One is df less than 3 by 7 xu. First we will consider this df less than 3 by 7 xu, and then second df greater than 3 by 7 xu, that is case number 3. Okay. So, let us consider this. When xu greater than df, okay, when xu greater than df and df less than 3 by 7 xu, right, follow the steps to find out the moment of resistance of T beam. Okay. Now, for this condition, okay, when the neutral axis outside the flange and df less than 3 by 7 xu, okay, for this condition the stress in the flange is uniform. This is a flange, okay, the stress in this flange is uniform. So, then what are the steps to be followed to find out the moment of resistance? So, first step as usual, okay, so we will going to calculate the depth of neutral axis, assuming it is outside the flange, that is xu is greater than df, okay, and assuming df less than 3 by 7 xu. It is assumption, we do not know, we will check that afterwards. Once if you find out xu, we will check whether this condition is right or wrong. But assume that xu is greater than df, and another factor, that is df less than 3 by 7 XU. So again see this is the total compression zone, this is tension. So now there are two rectangles, this is 1, this is 2. Now equate total compression force C to the total tensile force T. Here it is a compression force and here it is tensile force T. So total C is equal to total T, force. Now what is force? Okay, force is equal to stress into area. Stress into area. Now there are totally 3 blocks, but we will consider this is first rectangle and these two are the second rectangles. So what is the stress in this first rectangle? Now see, force is equal to stress into area. So what is stress? 0.36 FCK. So in this rectangle 1, what is the force? Stress is 0.36 FCK. And what is the area of this rectangle 1? See, it is BW into XU. See, BW into this rectangle 1. So area of this is BW into XU. So BW into XU is area, and this is 0.36 FCK is the stress. So stress into area is C. Okay, this is for rectangle 1. Now what is the C for rectangle these two? Okay, so there are 3 rectangles, 1 and these 2 and 2. Okay, this is 1. 0.36 FCK is the stress, area is BW into XU. Then what is the stress in this rectangle 2? Rectangle 2, 0.45 FCK. Here it is 0.36, here it is 0.45. So 0.45 FCK is the stress into area. What is the area of this rectangle 2? Now total is BF. So BF minus this BW, because already you have considered this BW you have considered for this rectangle. So total length of this rectangle 2 is BF minus BW. Okay, then this is length. What is the depth? Height? This is DF. Okay, so stress is 0.45 FCK and area is this BF minus BW and height is DF. Okay, length into breadth. So BF minus BW into DF will be the area of this. So here C 0.36 FCK BW into DF plus 0.45 FCK stress, area is BF minus BW into DF. Okay, that is equal to what is the total force, tensile force in this steel? Okay, again stress into area. Stress is 0.87 Fy in the steel and area is AST. Okay, so total C in this blocks is equal to total T. This is okay. So from this we can find out the XU value, that is depth of neutral axis. So once if you calculate this XU, okay, then second step is compare XU and DF, because in the first step we have assumed this. We have assumed XU greater than DF, assumption it is. But once if you calculate this XU, check whether XU is greater than DF or no. Okay, check XU and DF. If XU is greater than DF, okay, if XU is greater than DF, our assumption, what we have assumed, this is correct. What you are assumed, this is correct. Then check also, what is another condition we have assumed? DF less than 3 by 7 XU. DF less than 3 by 7 this XU calculated. If these two conditions are satisfied, okay, if these two conditions are satisfied, then go to the step number 3. Okay, calculate the value of XU max. Okay, calculate the value of XU max, that is maximum depth of neutral axis or XU limit. So for the given grade of steel, so see the grade, which grade it is, Fe 250, Fe 415 or Fe 500. Depending upon that, we are going to calculate XU max or XU limit. Then compare here XU and XU max. Compare XU and XU max. If XU is less than XU max, okay, if XU is less than XU max, the section is under reinforced T section. Okay, no doubt it is T section, but it is under reinforced section. Now calculate the moment of resistance. Next step, moment of resistance mu. So what is moment? Moment is equal to force into perpendicular distance. Lever arm means perpendicular distance. So force, that is C into perpendicular distance. Now mu is equal to, what is compressive force? Now see here. Compressive force is this total. This is C now. Same thing you have to write here. So 0.36 FCK, 0.36 FCK BW into XU, okay, plus 0.45 FCK BF minus BW into DF. So this is total C. So this C, that is force, see here, 0.36 FCK BW into XU into D minus 0.42 XU, okay. This is force C, 0.36 FCK plus XU into D minus 0.42 XU. Now this is lever arm. Now see here, this is force, okay, 0.36 FCK BW into XU is force into lever arm. For this, okay, lever arm is D minus 0.42 XU plus this 0.45 FCK, 0.45 FCK BF minus BW into DF. This is also C, or you can say that this is C1 plus C2. Okay, C1 into lever arm, C plus C2 into lever arm. So this is C2, that is 0.45 FCK BF minus BW into DF into lever arm. For both you have to multiply the lever arm. Here this is lever arm, this is, for this it is D minus DF by 2. See this is DF no. So the lever arm is the distance between this to center of this rectangle 2. So here to here it is D minus half of this DF by 2. Okay, so this is lever arm. Okay, so total C, this is C1 into lever arm plus C2 into lever arm. So that will give moment of resistance. So whatever you are written here, okay, 0.36 FCK BW into XU into lever arm, that is D minus 0.42 XU plus 0.45 FCK BF minus BW into DF into D minus DF by 2. So this will give the moment of resistance of this T beam. This is for second condition, that is when the neutral axis outside the flange but DF is less than 3 by 7 XU. DF is less than 3 by 7 XU. Now here condition what is? XU is less than XU max. Suppose in case if the XU is greater than XU max, okay, XU is greater than XU max, then the section is over reinforced section. Section is over reinforced section. Then don't change anything, only wherever XU is there, okay, wherever XU is there, you can put XU max. Okay, you can put XU max or XU limit. So if it is a over reinforced section, directly don't take XU, it is XU max. Wherever XU is there, you can put XU max. If it is under reinforced section, put XU, okay, then calculate using this moment of resistance. So this is second case. Now the third case, same it is, okay, neutral axis, it is outside only, XU is greater than DF, but condition is DF greater than 3 by 7 XU now. So here what you have considered? DF less than 3 by 7 XU. But here this case 3, we will consider DF greater than 3 by 7 XU. Almost it is same. See, all things are same. Only thing for case 3, that is when neutral axis outside the flange and df greater than 3 by 7 xu, in place of df, in the previous case we have taken this is df, but here for this case 3 we consider this is yf, another factor or another term, this is yf. Remaining things it is same. Okay, for this case the stress in the flange is not uniform. Now the stress in the flange is not uniform. Now what are the steps to be followed to find out the moment of resistance? As usual, calculate the depth of neutral axis assuming neutral axis outside the flange, that is xu greater than df, and assuming df greater than 3 by 7x, this condition. Now in the previous it is less than, but it is now greater than 3 by 7x. So equate total compressive force C is equal to total tensile force T. Same. Okay, C is equal to T. Now 0.36 FCK, same. Now see here, this stress into area. Stress is 0.36 FCK, area BW into XU. This is XU now. Okay, BW into XU. Okay, 0.45 FCK, 0.36 FCK, BW into XU plus 0.45 these two rectangles. 0.45 FCK is the stress, area is BF minus, this minus you have to mark now, BF minus BW into YF now. So this will going to take YF into YF, that is equal to total tensile force. Stress 0.87 Fy is the stress, area is AST. Same it is, in the previous case it is same, only thing wherever the DF is there you can put YF. Okay, wherever DF terms are there you can put YF for this case number 3. So the above equation, this equation is used to determine the value of XU. From this you can find out the XU and whether the condition DF greater than 3 by 7 XU you are satisfied should be checked. Okay, first find out XU. Okay, so if you want to find out XU here, you have to find out this YF value first. Okay, so what is YF value? In the above equation, YF is known as height of equivalent stress block. Okay, YF is, this YF is known as, we should not take DF now. For this case 3, you have to take this as YF, and YF is known as what? Height of equivalent stress block of uniform stress, and the value of YF is calculated like this. YF is equal to 0.15 XU plus 0.65 DF. Okay, 0.15 XU plus 0.65 DF. So from this you can get the YF, substitute YF. Okay, right. So then second step is now moment of resistance. You have to calculate the ultimate moment of resistance, that is mu. So again mu is equal to same compressive force C into lever arm. Okay, same thing. Now this is C into lever arm, then this is also C into lever arm. Okay, so this C, this total C into lever arm means C1 into lever arm plus C2 into lever arm. Okay, don't take this. So moment is equal to force into lever arm or perpendicular distance. So 0.36 FCK BW into XU. Okay, for this lever arm is D minus 0.42 XU as usual in the previous case plus 0.45 FCK BF minus BW into YF. Same for this lever arm is D minus YF upon 2. D minus YF upon 2. Now see here, check this equation. Same equation we are going to use to calculate the moment of resistance for the case 3. Okay, but change what you have to make here is, okay, wherever DF is there. Now see, DF is there now here. Okay, in place of DF you have to put YF. So this is YF into D minus YF upon 2. See. d minus yf upon 2. So this is the moment of resistance of T beam for the case 3. Okay, so case 2 and case 3 are important. Okay, case 2 and case 3 are important. Only changes you can observe in this case 2 and case 3. So case 2 is xu greater than df, that is neutral axis outside the flange, but df less than 3 by 7 xu. And case 3, same neutral axis outside the flange, xu greater than df, but df is greater than 3 by 7 xu. For this, wherever the df is there, you can put yf. Now see here also yf, so put yf. Okay, that is the procedure for to calculate the moment of resistance. So case 1, neutral axis inside the flange. Okay, how to calculate the moment of resistance we have seen. Case 2, neutral axis outside the flange, but df less than 3 by 7 xu. And the case number 3, xu greater than df, that is neutral axis outside the flange, but df greater than 3 by 7 xu. So based on these 3 cases, we will going to calculate the moment of resistance. So in the next class, we will going to consider the problems. Okay, first case 1 we will going to consider, then case 2, then case 3. We will going to solve the problems. So hope you understood this procedure. Okay, so once again go through these 3 cases. Okay, feel free to if you have any doubts. Okay, but understand the concept, how to calculate the moment of resistance. Okay, so we'll meet in the next class with problems on the calculation of moment of resistance of T beam. Okay, so thank you very much for attending this session. Thank you.